Today we're going to be going over wastewater management, so introducing the topic of wastewater management. The presentation is going to include just basics: what is wastewater management, how we reuse, recycle, and discharge and treat wastewater, what publicly owned treatment, how that works, how on-site and decentralized wastewater treatment works, if you have a septic system, and then with that comes soil testing, and then reasons for failure of those systems. So the basics of wastewater management: you try to reuse, recycle, or discharge and treat. So some relatively clean wastewater can be reused without treatment. So in your own house, some of the stuff that comes out of your sinks and your showers, for the most part, can be reused. It's called gray water. It's generated by washing, laundry, bathing, just not your toilets. Obviously, there's some stuff from the toilet that is toxic and dangerous and needs to be treated. But if you think about just washing, laundry, and bathing, about 50 to 80% of all your domestic water can be reused on site, for things like irrigation of your lawns, or if you have a garden or something like that. Or you could reuse it to actually flush the toilet. Um, Recycling, wastewater can be treated. So if you want to actually try to treat it on site, and instead of like sending it to a facility, again, you don't want to reuse this water for drinking purposes, but you could capture, treat, and so a closed loop system is where you capture, treat, and reuse water on site. But what happens most often is the water that we use will be sent to a treatment facility that we're going to be talking about in a few minutes. And then that's the water reclamation, involves treating it and then discharging it for or using it for a different purpose. And then finally, wastewater is transported to a treatment facility on-site or off-site, treated and discharged into a water body. The two different types systems here are publicly owned water treatment works. So, here at Maine East or Maine Township, pretty much everyone will live in a, urban or suburban area, and as a result, pretty much all of our water is going to be sent to a publicly owned treatment work. We don't live in a rural enough area that people are going to be having septic systems, but we will talk about how that works. That would be a decentralized wastewater treatment system. All right, so publicly owned treatment works, they're owned by the state or municipality. It stores, treats, recycles, and reclaims water, and it includes the sewers and the pipes and the treatment plants. So, when the water leaves your house, it leaves through pipes. Once it's off your property into the street, then it becomes property of the municipality or state that owns the system. All right, but once if it's still on your property in your house, or out in the yard in that pipe, then you're still responsible for it. So the way treatment works is when it actually is received into the plant, they do some large screening because, who knows what is actually being sent through these pipes. So sometimes you have to, screen out some large objects, and then some settling of those large objects. So the primary treatment, the first round of treatment is just screening and settling. Secondary treatment is once this material is put into tanks, you can do some biological treatment where you introduce bacteria or other microorganisms that can break down the solids, and it turns it into activated sludge, and it quote unquote eats the pollutants. So a lot of there's a lot of good bacteria out there that can help us in this process. And then the final stage is disinfection. So that's when you use chlorine or other chemicals to help kill bacteria, viruses, and protozoa. You don't want to discharge wastewater back into streams and lakes that still have that stuff in it, because then it can be a real harm to fish or people who are fishing or swimming or using that water in some way. So that's the 3-step process. And in order to make this all work, as with most things in civil engineering, there's codes because we've found what works and what doesn't work. So if you are looking at a typical sink, like in your kitchen or in your bathroom, you'll notice that the water comes in. It's usually pressurized. It's in smaller pipes, like half-inch diameter pipes. You might have some lines that are up to 3/4 to an inch, if that's the main service into your house. But once it gets to the faucet, it's usually about a half-inch pipe. Well, after that, once it's used, it goes into the drain. These pipes are a lot larger. They're inch and a quarter, inch and a half, and once they all collect together, once they start leaving your house, then or like the mains that are in the walls behind the sinks, they get to be 3 and 4 inch diameter pipes. If they're in a multifamily, like an apartment building, they might be 6 inch, or if they're in an industrial facility, they might be 8 inch. Once they leave the house, they must be pretty much at least 2 feet below the lowest floor. So that way, everything we basically we try as best we can to depend on gravity to do most of the work for us when getting rid of waste. So if when everything's being flushed down or washed down the drain, it all gets carried down to the lowest level, and your drains should hopefully be 2 feet below the lowest floor with any kind of sanitary sewage drainage. There are places, a lot of basements. If you have a basement with a toilet, you might have a pump that pumps it up to maybe 3 or 4 feet, 5 feet above that. Just because here in the Chicago area, everything's so flat, we don't have the always the ability to have it below the basement, but it might be 2 or 3 feet below the first floor. But it definitely also needs to be below frost depth, right? You don't want these pipes freezing and having issues during the winter. Where we're going to be spending most of our time in our calculations is this next item, the minimum sewer lateral slope. Again, we want gravity to do most of the work for us. So when sewage leaves your house, the pipe has to be sloped away from your house towards wherever the sewage is flowing to. And in order for the solids to be carried away, what they found is that at a minimum, you need 1/8 of an inch per foot, which is equivalent to about 1% slope. If you don't get that, then the solids will be left behind. Those fluids will flow away, and then you get it back up. And so part of it, you might need to have, you can have a steeper, or very occasionally you can have a less steep slope, but it all depends on the number of drainage fixture units, something we're going to talk about, and depends on code. And then another big thing is when you're laying this out, this doesn't always apply to older cities, or it does apply now for new construction, but a lot of older cities, you'll find that this wasn't always the case. They always want to keep a minimum of 10-foot separation, horizontal distance between water and sewer lines. So if you're putting in a fresh water line and a sewer line, you want them at least separated by 10 feet. That way, if one breaks, for example, if the sewer line breaks, it's not going to contaminate the drinking water. And then you want sewer lines at least 18 inches below the water line. Again, if a sewer line breaks, that will flow down. And if the sewer line is above the water line, then again, the water line can be contaminated. So nowadays, they definitely want water and sewer separated as much as possible. It's not always the case in older construction before a lot of these codes took place, but that's what the standard is nowadays. So this idea of drainage fixture units. So you want to size your drainage pipes so that they have enough capacity that if all the faucets and toilets are used at the exact same time, that the system won't overload and back up. So they call these, whatever the item is, they have a quote unquote drainage fixture unit associated with it. So any bathtub, any washer, clothes washer, or dishwasher is worth 2 drainage units. A floor drain, since it's not used almost ever, it's 0. But a kitchen sink's used often enough that it's 2. A lavatory, so like your sink in your bathroom, is 1. A lavatory tub, so again, any kind of like bigger tub that can have more stuff, it's 2. A shower stall is 2. A water closet, so that's where you get your toilet, that's worth 3. And a water closet that's like an older water closet that's not low flow is worth 4. And so when you're sizing the drain that leaves your house, you need to kind of add up all this stuff in your house, and then figure out, you know, so you, if oops, back a second. So if you add them all up and you have a 30, equivalent to 36 drainage fixture units, you need a 3-inch pipe that is sloped 1/8 of an inch away. All right, if you put in a 4-inch pipe, you can have up to 180 drainage fixture units in your house and still have only a 1/8 inch slope. Whereas if you want to stick with a 3-inch diameter pipe, and you have more than 36, you have to, if you go up to 42, you have to have a steeper slope of a 1/4 inch. If you go up to 50, you need a much steeper slope again of a 1/2 inch. All right, so the more drainage fixture units you have, again, the more likelihood you'll have more solids being drained away, and more solids, you need more slope. But if you have a larger diameter pipe, you can have less slope. Just kind of the basics of why that works. But in general, no less ever than 1/8 of an inch per foot, because less than 1/8 of an inch per foot, solids will not be carried away and your pipe will back up. All right, so how all this works, it's kind of like math class where it's you're just calculating slope, but of course, we can't just put it on a grid system and do 2 points and change an x or change an y. It is essentially rise over run, but it's change in elevation over the distance from the building to the main. All right, so this picture is what we're going to be basing everything off of. You have your building drain, you have your building sewer, or sewer lateral meaning it goes sideways for the most part. And then this is your main that's usually out in the street somewhere. All right. You almost always, if you look somewhere it's either in your house or in the yard, you'll have a clean out. So that way, if anything ever gets clogged, you have some way to clean it out. I know I had this happen to me when I first bought my house. The house had sat empty for about a year or so, and it was inside the house before it reached the main sewer drain. From the kitchen sink, there was a bunch of grease that had solidified. I tried to clean it out myself, popping some of these cleanouts off and putting like a little snake down through it. Didn't quite work, so I had to get a plumber to do it. But that's why you have these things, is to be able to clean it. You have them spaced every 25 to 50 feet for smaller stuff, and larger, in your mains outside. That's what you have your, you see the manhole covers. That's essentially what those are. There's just large cleanouts so that a person can get down in there, put tools down through the pipes into the next manhole and try to clean them out if a break happens or if a clog happens. All right, so the flow obviously wanted to go with gravity downhill. Your elevation, so it's the elevation from you see the top invert elevation, that top red line. So it's from essentially the bottom edge of the pipe when it leaves your house to the bottom edge of the pipe when it gets to the sewer main. That's the change in elevation right there. So that's the top of your equation. That's what we're trying to check out, is to make sure that drop in elevation is enough compared to that distance from the building. So once the main leaves your house to the center line of the sewer main, that's your distance from the building. All right. So that's the concept. So I want to make sure we go over the concept before we jump into numbers. All right. And so here's kind of the equation we're going to use. We're going to use in our class, we're going to use a slightly different equation that gives us the numbers right away. I've incorporated, factors of 12 to, account for converting from inches to feet, because a lot of pipe diameters and stuff is given to us in inches, but our distances away from the house are given in feet, so we have to make some conversions. But essentially, uh, we'll go over this and make sure it all makes sense. All right, so again, this is kind of your basic equation. We're going to use a slightly modified version in our class that's going to give us the answer right away. Again, using the conversion rates for our factors from inches to feet and feet to inches. All right. All right. So that's the system that, for most people in the main township, will have a sewer that attaches to like the county or township. If you live in a more rural area, you might have an on-site and decentralized wastewater treatment system, so like a septic system. So what it does is it collects, treats, and disperses or reclaims wastewater from individual residents, businesses, or small clusters of buildings, used when there's no municipal system available. So actually, maybe there's a possibility that if you live in unincorporated Des Plaines, you might have this. About a quarter of all residents in the U.S. and 33% of new developments, since new developments a lot of times are further away from, downtown areas, use this. It's usually called a septic system, private sewage system, individual sewage treatment system, on-site sewage, or packaged plant. All right. So kind of throughout the U.S., you can see here in Illinois, we have usually less than 25%, but more rural areas, you can have more than half. So, certain states have quite a few of them. The problem with these is sometimes they fail. 10 to 30% will fail on an annual basis, and especially if they're older than 30 years. And, that picture on the right is scary as anything to me. A kid playing anywhere near this, they get very, very sick. So what's needed? So the basic system is, you see the house there, a pipe leaves away, you have a septic tank, which kind of collects all the solids, and then after the septic tank, it drains out into what's called a drainage field, so a lot of the liquids will drain out into a drainage system. And then the whole idea is that it drains down. Earth and soil is the best filter available. And so if it drains down, it filters out all the bad stuff before it reaches the ground level, or the groundwater level. Septic tanks. So basically, the concept is, from the left, the inlet, you have septic, the stuff coming in. It falls into the tank, and then all the solids fall to the bottom, and then the liquids will stay up at the top. And you have this stuff here. You have an air layer, a scum layer, and effluent to be discharged, and then all the liquids will go to the outflow to the drain field. Sludge, heavy solid, settles out. The scum, grease, oil, floating debris rise to the surface. You have anaerobic decomposition that breaks down some of the solids. But again, you want to, especially the scum, the grease, the oil, all that stuff, that's not good stuff. You want to pump that out on a regular basis. This is an example of it being a septic system being installed. So how does it work? So the concept is, you put in, so the wastewater goes into a septic tank. From there, the liquids flow out into a distribution box, out to a drain field, and then the liquids drain down into aerobic soil, where it all breaks down before it reaches the groundwater, so you don't contaminate your groundwater. But again, it doesn't take that many, like maybe 2-3 feet of soil to really clean out most, really filter out all that bad stuff. In order to install a septic system, you need to test the soil beforehand, check with local building department, do a percolation test. A perk test really is just digging a big hole, pumping it full of water, and then measuring it to make sure that the water flows, drains out of that hole fast enough, because if it doesn't drain out fast enough, it will build up and not work. So if you're really clayey soils, it won't work. But if you have nice sandy soils, it will work just fine. And you also need to be concerned about the length of the drain field pipes based on the infiltration rate. So if you have a faster infiltration rate, you can have shorter pipes. A slower infiltration rate, you need longer pipes to spread the liquid out over a longer or a larger area. Reasons things don't, the reasons they fail: poor soils, like I said, you have a lot of clay soils. If the water table is too high, the discharge is going to encounter the water table too fast and contaminate it. If the system's not sized appropriately, and so you have a smaller system for too large of a house or too large of a building, bad construction, or more likely bad maintenance. So you need to maintain your system on a regular basis. All right, so that's it for the introduction.